Hi, I'm Prentice Weathers, the product manager for Side Power Stabilizers here at IMTRA. And we're going to talk about the fin installation tool and its purpose and how to assemble it. So the fin installation tool is a hydraulic pump made by SKF, who are best known for bearings. And the process or the tool is used for installing bearings and systems, shafts, that kind of thing. Side Power is using it to install the fin stabilizers, stabilizer fins, excuse me. The reason Side Power uses this system as opposed to others has a lot to do with the fact that the vector fins are curved. They're not straight or flat like all the other fins. And as a result, since the fins are curved, the shaft buried inside of the fin can't penetrate straight down and be accessed from the bottom. So we have to come up with a different system. This is an example of the end of the shaft, and the principle is pretty basic. This section is buried in the fin in the smaller Side Power sizes, the SPS 55 actuators, which use the VF 650 and VF 800 fins. And in those instances, the shaft actually goes up into the actuator. In the case of the larger sizes, everything's reversed. This is actually installed in the actuator itself, and we're going to marry the fin onto the tapered shaft. But the principle is the same regardless. We have a very smooth tapered shaft. We're going to, and we have a ring here. There are, I don't know, a dozen or so studs with nuts on them underneath. And the principle is to drive this tapered shaft up into the actuator, or down into the fin, depending on the fin size, tightening up the nuts as we go, and use that mechanical advantage of the threads to pull the shaft up into the actuator, or vice versa, as I say, all the while expanding the cavity so that this taper can go be engaged up into the receptacle. The receptacle is actually a little bit smaller in dimension than the shaft, so the hydraulic press, the hydraulic pump, is used to physically expand the cavity with very high pressure as we mechanically pull this up into place. Because we're relying on friction to hold this system together, the condition of this surface is critical. It must be maintained clean, keep dirt, everything out of there, because that will kill the system. The shafts are sent with a protective cover. These should be kept on the boat when you remove a fin, or when you're installing a fin in the first place. Make sure that these are on the boat and that somebody knows where they are in case you ever have to remove a fin. So I'll put this aside, and now we'll go through the components. The most important thing is actually the grade of oil. This is supplied by SKF, the tool manufacturer, and it's labeled quite clearly as SKF mounting fluid. There's a part number in here, LHMF 300/1. You have to use this oil. No other substitute is acceptable. When you buy the tool from IMTRA or Side Power, it comes with a liter of the correct oil. Additional oil is available from SKF distributors. We happen to use TE Equipment. They have a branch in New Jersey, which is convenient for us, but this is an international company, and they're available. The oil is available in a lot of different places. You don't want to wait to the day of to get this, so make sure that you have enough oil. You probably use about a third of a bottle per installation, maybe a little bit less than that. So make sure you have enough and extra as possible. So the basic components of the pump are this innocuous looking pump itself. It mounts this way, and there's a handle that just simply pumps it up and down. Doesn't look like much, but it's capable of generating 43,000 psi. Most thruster systems operate at 3,000 to 4,000 psi, most windlasses 2,000, that kind of thing. This is 43,000. So it's not a toy, and it needs to be treated with respect. Like any hydraulic system, dirt is a killer. And this is particularly important to keep in mind when you're working underneath a boat. You have sand and barnacles, stuff all over the place. You need to make sure that you keep this tool and that shaft that we looked at earlier absolutely clean. You're going to need some oil sorbs underneath the fin because you will get some oil dripping down the fin and onto the ground, so be ready for that. The other component is the base, another component, the reservoir, the handle, the support, and then the high pressure hose with fittings. And then the last item is the adapter that goes into the actuator. We'll look at that later. First thing I do is take the, well, I think actually the first thing I'll do is assemble the pump. So we are going to take this thread, insert it in here, and with any metal-on-metal system, you want to make darn sure, whoops, that you get that you don't cross the threads. Metal on metal, fine thread, be careful. I'm going to assemble this in on the high side, and that will give me clearance for my pump handle. The next thing I'm going to do actually is insert this, this support. And there's a locking lever here, which is just simply a screw, which is going to engage this base. There's a little detent, ball bearing detent. Push it, extend this out beyond. Hopefully it catches that other detent. And then we're just going to simply insert it in here and then lock it in place. So that's the principle there. That's going to give us some support when we're operating this. The next component is the high pressure hose, and this is actually a piece of pipe with some protection on it. One thing to keep in mind is that you can't kink this pipe. There are instructions here as to the minimum radius of 100 millimeters, which is about 4 inches. And the idea here is that there are no O-rings or seals or that sort of thing. This is all, the whole system relies on mating surfaces, conical mating surfaces, meeting up with each other. So all I'm going to do, again, this is very stiff and it's a little unwieldy, so forgive me if I'm a little bit cumbersome here, but clumsy. So again, like the pump, I'm going to engage this hose and screw it all the way in. And I'm going to basically screw the pump just about all the way in. I don't want it to end up like that. That's inconvenient. So I'm going to orient it vertically, and then I'm going to cause the mating part to butt up against it. And if I'm looking down in here, and I can see the ball mating up with the cup surface of the pump. I'd like to sort of keep an eye on the pipe and make sure it's centered. And then when I've taken it all up by hand, I'll just take this last part and just give it a little nudge. I didn't give it much. I'm using a standard 10-inch adjustable wrench, holding it here and just giving it a good firm torque. And this is basically the assembly. The last thing I'm going to do is take the hydraulic reservoir, and in theory, this has a little ball on the end, so you can fill it up and move it around and assemble it, and it won't drip oil. One way to fill this is to decant the oil into a clean bucket or clean tub, and then pull this lever up, and you're sucking oil up past the one-way valve in the process. Another way to do it, which I think is more convenient, particularly in a harsh environment, is actually to assemble this onto the pump, and then remove the top. There are advantages and disadvantages to each. Take it off again, keeping dirt out of this. The plunger has an O-ring, a spring, and that's what's providing positive pressure to push the oil down to the pump. You've got gravity feed, so you don't really need the spring to provide that. There are some instances where this reservoir might be pointing off to the side, but we're not going to get into that, and that's where the spring will come in handy. But anyway, I remove that, take my SKF oil, mounting fluid, pour maybe 2/3 of the reservoir full, insert the plunger, thread it down again. It's a little bit cumbersome to get this thread started. When there's oil in the reservoir, this will have been, well, I can't pull it now because it's engaged. This will have been part way up, so you need to sort of hold that up and screw the top on. But if I can do it, you can do it. So here's the complete assembly. And really that's all there is to it. The remaining component, which we don't need to put on now, but I'll just explain to you, because we'll show you how to assemble this to the actuator. Again, you've got a conical surface here. That's actually going to end up mating to this adapter. This is going to thread in, give it a little tug, and that adapter is now going to go into our fin. There are 2 ports on the fin. One is labeled on, I don't know if you can see that or not, and the other one is labeled off. When we're installing a fin, we're going to remove both of these plugs. We're going to take the adapter. Since we're installing the fin, for instance, I'm going to thread this into the on port. If we were removing the fin, we'd thread it into the off port. Once that's threaded all the way in, I'll re-engage my pipe, and we're ready to go. One option in using and assembling this tool is actually to use a gauge as well. Typically, we don't use the gauge because we don't know how much, there's no such thing as the correct amount of pressure to use when you're installing the fin or when you're removing the fin. The purpose of the gauge in our application is more informative. When you pump the handle, assuming this is already installed, I'm doing it with one finger, and actually when you start building, because there's no pressure in the system, when you start building pressure, there still isn't very much pressure on the handle at all. So a lot of people wonder, am I really building up pressure? Nothing's happening. I'm pumping. You can use the gauge to sort of give you peace of mind, and it's a bit informative. I've found that I can use it just fine without the system just fine without a gauge. But if you want to use it, there's a slight difference in how you assemble the pump. Instead of the pump and the mounting and the hose or the pipe butting up against each other, so the conical surface of the pipe meeting up against the conical cup surface of the pump, we're going to insert this adapter, which is onto which the gauge is threaded. And this adapter has those mating conical surfaces. So you're just going to drop it in from the top. It's going to assume the correct attitude. We will thread the pump in. You can see it engaging this now. Okay, that's not much help, so I'm going to back this off a quarter turn so that the reservoir is going to be pointing more vertically. And so my pumping action can be up and down as opposed to sideways. And then I'll take up the rest of the tension with this nut. Again, you'll take an adjustable and just snug it up. Now we have a gauge in line with between the pump and the hose, and I have no idea what pressure you're going to read, but it'll give you some feedback. Thanks.